guys, Mrs. Brummel here. This is the last video for 3.4, just 3 examples, but we're gonna show you a tool that's called Logarithmic Differentiation. This isn't one that's like required, but it's something that can make your life a little bit easier if you have kind of a gnarly expression. And so basically how it works is we're gonna use the rules of logs. So a couple things to remember. I'm just gonna write some generic log rules up here, and I'm just gonna use natural log. So if I have natural log of 2 things being multiplied, we can separate that into addition. If I have 2 things being divided, I can separate that into subtraction. And if I have natural log of something to a power, we can pull that power down front and multiply. So those are just some log rules, you guys, that you learned previously in both Algebra 2 and Pre-Calc. And so basically that can help us deal with something that looks like this instead of a product or a quotient. And so that can make finding the derivative a little bit easier. So we're going to show you kind of how that works. Okay, so what I'm going to do here, you guys, is I'm actually going to take the natural log of both sides of this equation. So I've got natural log of y equals... So here, when I take the natural log of this whole thing, because this is division, I can separate it into subtraction. So I get natural log of x squared minus natural log of 3x minus 2 to the third. And then these exponents can actually come down in front as well. So I'm going to get natural log of y equals 2 natural log of x minus 3 natural log of 3x minus 2. So I haven't differentiated yet. All I've done is I've rewritten this expression. It's still an equivalent expression. It's just now in terms of sums and differences instead of a quotient. So that can just make finding the derivative a little bit easier. So now I'm going to differentiate. So derivative of natural log of y is 1 over y dy dx, which dy dx, remember, is the same as y prime. So that's why they're writing this tool here. You are welcome to use that as well. 2 times the natural log of x is 2 times 1 over x, or 2 over x, minus 3 times the natural log of this, which becomes 1 over that, times the derivative of that inside function, which is just going to be 3. Okay, so we can simplify a little bit. I'd like to get dy dx by itself. So I can multiply that and get a 9, and then I'm going to multiply both sides by y. So I've got 2 over x minus 9 over 3x minus 2 times y. And then lastly, if I want this all in terms of x's, I can replace y with my original function. So we can say dy dx equals 2 over x minus 9 over 3x minus 2 times y, which is equivalent to x squared over 3x minus 2 cubed. So that is another way that we can differentiate. Now we would get something of equivalent. It might look slightly different depending on how it's simplified, but we could get the same thing using the quotient rule. So it's just another way to differentiate, and you can use it when it makes your life easier. So we're going to try it on this one as well. So I'm going to apply natural log to both sides. Again, I haven't differentiated yet. I'm just rewriting this equation in an equivalent form. So when I take the natural log of this side, I can bring the x exponent down in front. So it's going to turn into that. Now I can differentiate. So I've got 1 over y dy dx equals, here's a product, so 1 times the natural log of x plus x times 1 over x. Simplifying here a little bit, so this becomes just 1. Right, did I do that right? Natural log of x plus, yes, okay, good. And so I get 1 over, dy dx, 1 over y equals natural log of x plus x times 1 over x, which is just 1. Multiply everything by y to get rid of the 1 over y here. So I'm going to get dy dx equals natural log of x plus 1, and then times y. And again, we can replace y with the original function x to the x. So that is going to be our derivative. Okay, lastly, we are going to find the equation of a tangent line, which we have done this a lot. And we're going to find it to the graph of f of x, and we want it to be at the point. Again, I just see that this is kind of an ugly expression that involves a product rule and a quotient rule. So I'm going to do it using logarithmic differentiation, so I can just split this apart. So I'm just going to take the natural log. I'm going to treat f of x as y. Okay, so when I take the natural log of this is a product. So it becomes natural log of x plus natural log of x squared plus 3 to the 1/2. That's the square root part. And then minus, so this is the product. When I split logs, the division becomes subtraction. So it's going to be the natural log of 1 plus x. And then one last thing, you guys, I could bring this 1/2 down in front as well. So I'm going to go ahead and do that. Okay, so now when I differentiate, so I get 1 over y dy dx equals 1 over x plus 1/2, the 2 is going to be on the bottom. This is going to go in the denominator. Now, chain rule, I got to multiply by the derivative of that inside, which is going to be 2x. Okay, and I'm just going to go ahead and put the 2x in my numerator. Okay, minus, over here, same thing. We get 1 over 1 plus x, and the derivative, that's just 1, so it's not going to change anything. I also see I could cancel my 2's right there. And then I'm going to go ahead and multiply both sides by y to get rid of the 1 over y. So I've got 1 over x plus x over, I guess I don't really need those parentheses anymore. I canceled the 2's, x squared plus 3 minus 1 over 1 plus x times y. Okay, and I can replace the y again with the original function. I don't have to though here because they want me to find it at this point. So there's an x and a y, so it kind of makes sense for me to just leave this as y. So I'm going to plug in 1's for every single x and y. So I get 1 over 1 here is 1. 1 over 1 plus 3 is 1/4. 1 over 1 plus 1 is 1/2. And then times y is 1. All right, so here I get 5/4 minus 2/4. I end up with 3/4. So that is our slope at this point. So we are going to write the equation of the line. I'm going to use point slope form. So y minus 1 equals 3/4 times x minus 1. All right, guys, that's it for this video. Thanks for watching.